So next point is angular position measurement with gyroscope. Okay, so basically gyroscope is used to measure the angular velocity in terms of units is degree per second or resolution revolution per second. Okay, basically gyroscope is used to measure or maintain rotational motion. MEMS means micro electromechanical system. Okay. Okay. Then some points related to the gyroscope, why gyroscope is used, basic principle of gyroscope, how to find the angle of tilt. So first one is why gyroscope is used and where they are used. So gyroscope are used in compasses and automatic pilots on ships and aircrafts. Also in steering mechanism of torpedoes and the inertial guidance system installed in space launch vehicles, ballistic missiles, and orbiting satellites. See the where it is used in gyroscope. And basic principle of gyroscope is it consists of spinning mass and rotate around its axis. Means XYZ three-dimensional axis. If a gyroscope is installed on gimbals that allow the mass to navigate freely in the three direction of space, its spinning axis will remain oriented in the same direction even if it is changing direction of three direction means x, y, and z. Then how to find out the tilting angle? With reference to the earth ground plane, it is used to accelerometer. Typical application can be found in the industry and in game controllers. Also in aircraft, the ball in turn coordinators or turn and bank indicators is sometimes referred as a inclinometer. So these points are related to the gyroscope. Then gyrosensors. So gyrosensors are also used to measure the angular velocity. It simply changes the angular velocity in change in the rotational angle per unit time. Means angular velocity is generally expressed in degree per second. Degree per second. Okay. Then next, wait for 5 to 10 minutes. Electricity connection is lost. So next point is hot wire anemometer. Wait for 2 minutes, just system is started. Due to electricity problem, wait for 2 minutes. Within 2 minutes, lecture will be start. So next point, Sudarshan Mali. Okay. So next point is hot wire anemometer. This hot wire anemometer is used to measure the velocity and direction of the fluid. Okay, means this is a device is used to measure the velocity and direction of the flow of fluid. Means you have to take one wire or probe, then you have to put in this wire or probe in fluid and transfer the heat. Means you have to measure the temperature up and down with the help of hot wire anemometer. Also, hot wire anemometer is used to measure pressure in gases, liquid discharge, pressure in liquid, gas velocities. Also, they are used to measure instantaneous flow velocity. Okay. So give the heading hot wire anemometer. Hot wire anemometer. Write down. It is a device. It is a device used to measure the velocity and direction of fluid. The velocity and direction of fluid. Stop. By measuring the heat loss of by measuring the heat loss of the wire which is placed in the fluid stream, which is placed in the fluid stream. Means it works on the principle of transfer of heat from high temperature to low temperature. From high temperature to low temperature. Okay. Same principle is there. Then hot wire anemometer consists of two main parts. First one is a conducting wire and second one is a piston bridge circuit. Means conducting wire, they are used to absorb or conduct temperature, minimize and maximize the temperature. So conducting wire is housed inside the ceramic body. The wire are taking out from the ceramic body and connecting to the Wheatstone bridge. And Wheatstone bridge circuit is used to measure the variation in the resistance. Means conducting wire are used to measure the temperature variation, and Wheatstone bridge circuit is used to measure the variation of resistance with the help of hot wire anemometer. Okay. These are the in hot wire anemometer are two types mainly. First one is a constant current method and second one is a constant temperature method. So give the heading constant current method anemometer. Give the heading constant current method anemometer and draw this diagram. Give the heading constant current method anemometer and draw this diagram. Draw it fastly within 2 minutes. After 1 hour, we are going to conduct practical. Om Metkari, roll number 28. See the construction of constant current method. Here name is also constant current, means here flow of current is constant, also resistance with the help of stone bridge is constant, means voltage is also constant and current flow through in current in this method also constant. Okay, see the construction. This is stone bridge circuit is there, rheostat, source supply, battery, and here gas flow and gas flow out, in and out. Here you have to measure the flow rate with the help of heat wire and constant current. Okay, so in this constant current method, anemometer is placed in the stream of fluid where the flow of fluid is measured. Anemometer placed in the stream of fluid flow, there measure the flow of fluid. The current of constant magnitude is passed through the wire. The Wheatstone bridge is also kept on the constant voltage, means current and voltage is constant. Okay, see, when the wire is kept in the stream of liquid, in case of the heat is transferred from the wire to the fluid, means wire is kept on the stream of fluid, then heat is transferred from the wire to the fluid, means the heat is directly proportional to the resistance of wire. Then heat reduces, it means the resistance of wire is also reduces. The heat is directly proportional to the resistance of this wire. Heat is increased, resistance is increased, heat is decreased, resistance is decreased. Then the Wheatstone bridge measure the variations in resistance, which is equal to the flow rate of liquid. Here Wheatstone bridge circuit is used to measure the variation in resistance, which is equal to the flow rate of the liquid. Okay, so write down, in constant current method, the anemometer is placed in constant current method. The anemometer is placed in the stream of fluid whose flow rate needs to be measured. Whose flow rate needs to be measured. Full stop. The current of constant magnitude, the current of constant magnitude is passed through the wire, is passed through the wire. Full stop. The Wheatstone bridge is also kept on the constant voltage. The Wheatstone bridge is also kept on the constant voltage. Then write down, the heat is directly proportional to the resistance of wire. The heat is directly proportional to the resistance of the wire. Full stop and next line. If heat reduces, if heat reduces, that means the resistance of wire also reduces. That means the resistance of wire also reduces. Full stop and next line. The Wheatstone bridge measure the variation in resistance which is equal to the flow rate of the liquid, which is equal to the flow rate of the liquid. The second type of anemometer, constant temperature method. Give the heading constant temperature method anemometer. Give the heading constant temperature method anemometer and draw this diagram. Fastly draw this diagram within 2 minutes. See the construction and working of constant temperature method anemometer. Okay. Same diagram will be there. Only here voltmeter is used to measure the changes in voltage. Huh? So in this construction or arrangement, heat wire is heated with the help of electric current. Okay, and this hot wire is placed in fluid stream to transfer heat from wire to fluid. Then temperature of wire changes up and down, also changes the resistance of fluid. Okay, so it works on the principle that the temperature of wire remains constant. Then the total current required to bring the wire in initial condition is equal to the flow rate of gas. I repeat, it works on principle that temperature of wire remains constant. Means here the temperature of hot wire is remains constant. The total current required to bring the wire in initial condition is equal to the flow rate of gas. Okay. So write down under the heading constant temperature method anemometer. The wire is heated by the electric current. The wire is heated by the electric current to stop. The hot wire is placed in the fluid stream the heat transfer from wire to the fluid. Thus, the temperature of the wire changes. Thus, the temperature of the wire changes which also changes their resistance. Which also changes their resistance. Full stop and then write down. It works on the principle that the temperature of wire remains constant. Full stop and next line. The total current required to bring the wire in the initial condition is equal to the flow rate of the gas. Is equal to the flow rate of the gas. Okay. The next point is turbine meters. Next point is turbine meters. Before starting the turbine meters, anyone please tell me what is mean by turbine and where they are used. So turbine is a device. There are a number of blades are connected, and they are used to convert rotational energy or angular acceleration or angular flow to convert to produce the electricity or generate the electric current. Okay, so their flow meters, also flow sensors are used to measure the rate of flow of fluid. Okay, so turbine meter is a volume sensing device, means liquid or gas passes through the turbine housing. It causes the freely suspended turbine blades to rotate. The velocity of turbine rotor is directly proportional to the velocity of fluid passing through the flow meter. Then flow meter or flow sensor, they are used to measure linear, non-linear, mass or volumetric flow rate of the liquid or gas. Means flow meter is basically used to measure the flow rate of gas or liquid. Whereas turbine meters also are used to measure the flow rate of gas or liquid. Okay. So write down under the heading turbine meters. After this point, I give it to 10 minutes break. Then join the next meeting. Turbine meters. A turbine flow meter is a volume sensing device as liquid or gas passes through the turbine housing it causes Rushikesh, it causes the freely suspended turbine blades to rotate. Wait, don't place your roll numbers. Vishal Ganthade, still lecture is going on. Why you are placing the roll number? Pritam, the velocity of turbine rotor is directly proportional to the velocity of fluid passing through the flow meter. Passing through the flow meter. Full stop and next line. A flow meter is used. A flow meter is used to measure linear, non-linear, mass or volumetric flow rate of a liquid or a gas. Or a gas. Full stop.